Unit 5, Day 4, Similarity in Right Triangles. The geometric mean of two positive numbers a and b is the positive number x where this proportion is true. If you set up a proportion and the two numbers you have are in the opposite diagonals, and then you have x in the opposite diagonals, when you cross multiply and solve this proportion, you'll find that x is equal to the square root of a times b. Let's find the geometric mean of these two numbers, 3 and 12. So this means we're going to set up a proportion where 3 and 12 are in the opposite diagonals, and we have x and x in opposite diagonals. Then we're going to cross multiply. X times x gives us x squared. 3 times 12 is 36, and then we take the square root of both sides, and we end up with x is equal to 6. Let's find the geometric mean of 4 and 8. So again, we're going to start off with our proportion, 4 and 8 in the opposite diagonals, x and x in the other ones. Then, when we cross multiply, x times x is x squared, 4 times 8 is 32. This time, when we take the square root of both sides, 32 is not a perfect square, so we need to simplify that radical. So 32 is equal to 16 times 2, and then we want to break down 16, which is equal to 4 times 4, and we bring down that 2. Now, those are going to pair up. One of them gets out, one cancels, and the 2 is stuck underneath the radical. So our final answer would be 4 times the square root of 2. The similar right triangles theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. What that means is you have this original right triangle, ACB. Then, from the right angle, if we drop down this perpendicular segment to the other side, we create these two smaller triangles inside of that right triangle. This theorem tells us that these two smaller triangles are similar to each other and also to the original triangle that we had. In order to see the three triangles a little better, we're going to use this diagram to separate the triangles. So we're going to take this outside shell of triangle ABC, and we're actually going to create three triangles that are just like it. Then we're going to mark and relabel our triangles. So first, we want to look at these angle markings. That's where our right angle is. We're going to mark A with 1, that top one, and we're going to mark this bottom one with 2. Now we're going to focus on one triangle at a time. The initial triangle that we have, ABC, we're going to label those vertices just like we see it, A, B, and C. Next, we're going to take a look at this red triangle, and we're going to mark those angles. Here's the right angle marked with D. So we're going to come to the right angle and label it D. Angle C is marked with 2, so we need to take this angle marked with 2 and label it C. The final angle of our red triangle is B, so this one needs to be B. Then we're going to take a look at our other triangle, this blue one, and we're going to do the same. Because this is perpendicular, this is our right angle, which is also D, so this is D. In the blue triangle, A is marked with 1, so we need to label that angle with A. And our last remaining angle is angle B. Once we set it up this way, we can see all three of our triangles in the same orientation so that the angles and corresponding sides are all in the same position. So when we're writing our similarity statement, it makes it much easier. We can say that triangle ABC is similar to triangle BDC is similar to triangle ADB. In this set of problems, we need to use the diagram to complete the proportions. But we have 3 different triangles we're talking about in this diagram, so in order to see them a little better, we're going to separate the 3 triangles just like we did on the page before. This way we'll be able to see a little more clearly as we talk about them. So we're going to make our angle markings, 1, 2, and then our right angle. So these are all 2. This one's marked with 1. And then of course we have our right angle here. So our very first triangle is exactly the same as the original, JMK. So we'll label J, M, and K. Then our next one, we have our blue triangle. L, again, is going to be our right angle. M is the angle that's marked with 1, so we need to put M up here with the angle marked with 1, and K is going to be our other angle. In our other triangle, this red one, we have L is the right angle, J is the one marked with 2, and then K is the other one. So basically we've just taken our 3 triangles and we've redrawn them so they're all facing the same direction. Now, we want to take a look at each of these proportions. Right now we have KM over KL. So we need to find the triangle that has both of those segments. Here we have KM and KL. Oh, sorry, KL. So we're going to highlight side KM and side KL. We're talking about the bottom and also the hypotenuse. So the other thing you need to notice is that KL corresponds to JK. Since KL is on the bottom, we need to find the triangle that has JK on the bottom. So that's this one. Now, the corresponding side that we need to complete the proportion is side JM. So in here, we're just going to write JM. Now we're going to take that same idea with the others. So here if we need to find the triangle that has LK and LM. So here we have LK and LM. So LK is along the bottom, LM is along the right side. Now, we need segment LK to correspond with LM. LM is on the right side, LK over here corresponds. So the side we need to complete the proportion is segment JL. Lastly, when we take a look at JK and KL, we have JK and then KL here on the same triangle. So here's segment JK, here's segment KL, the hypotenuse in the right side, and we need segment LM to correspond with KL. Here's KL, and then here's ML to correspond with it. So we need the corresponding side, MK, to complete that proportion. In this problem, it asks us to write a similarity statement for the 3 similar triangles in the diagram, then find the value of x. So the very first thing, again, in order to see them a little more clearer, we're going to separate out the 3 triangles. And then we're going to mark our angles and then label our vertices. So we have this one on the top is marked with 1, this one's 2, and this is our right angle. So we have 1 across the top, 2. And then we have our right angle. The very first one we want to label A, C, B. So we have A, C, B. Then when we look at this triangle, our blue one, D is the right angle. Then A is the one marked with 1, and C is our other one. When we take a look at the red triangle, we have D is the right angle, B is the one that's marked with 2, and C is our other angle. Now, the last step, which we didn't have before but we do now, are these values. So we need to find segment AC and label it with X. We have AC here, and we have AC over here. Segment AD is equal to 5. So we find AD here, and that's the only time we find AD. Segment DB over here is 3. Now look carefully here. We have the segment AB is equal to 5 plus 3. So the segment AB is equal to 8. So here where we find AB, we can also label that 8. Now, let's look carefully at the information that we have, because we need to set up a proportion. We have a measurement here and here. We have one here and here, and we also have one here. So you want to look at the information that you have and determine which two triangles have two pieces of information in the same corresponding parts so that we can set up a proportion. Now in these two triangles we have the left side and the hypotenuse, left side and hypotenuse. In the third triangle we only have the bottom piece. So we're going to use this one, okay, and this one to set up a proportion. Now X corresponds to 5, then we have 8 corresponds to X. Then we're going to cross multiply, and we end up with X squared is equal to 5 times 8, which is 40. Now we can take the square root of both sides, and then we get X is equal to, we cannot take the square root of 40, so what we're going to do is we're going to simplify this. We get 4 times 10. 4 breaks down to 2 times 2, and then 10 breaks down to 2 times 5. So the 2's pair up. 1 gets canceled out, and 2 and 5, they don't have anyone to pair up with, so they just multiply and stay inside the radical. So your final answer is X is equal to 2 times the square root of 10. Now I know that some of you are going to need to work on setting up your proportions, and then some of you will need to work on this algebra work of simplifying radicals, but we're going to need to work on both of these. Okay, that's all.